Hi, I want to do a very simple example of how we perform binary multiplication. So we should know that the binary alphabet, or the number system, only consists of zeros and ones. Okay, so the rules of multiplication are quite simple. So we have 1 multiplied by 0 gives us a 0, or 0 multiplied by 1 gives us a 0, or 1 multiplied by 1 gives us a 1. Okay, so these are our rules, yeah. And actually, multiplication is really only addition, right? So once we expand out the actual multiplication, well, then it just turns into an addition kind of problem. So if we were to take a very simple example, maybe as a demonstration, if we think about the number, we take the number 11 multiplied by 5. When we say 5 multiplied by 1 gives us 5, 5 multiplied by 5 gives us 5. Okay, and this is all in base 10. Okay, so the answer that we're going to be trying to get to is 55 base 10. So, well, the number 11 in binary, well, that's equal to 1, 0, 1, 1. And now the number 5 is 1, 0, 1. So we have 1, 0, 1, 1 multiplied by 1, 0, 1. And now, so to actually perform this multiplication, it's really straightforward, okay? So when we think about it, if we were to grab and start off with this particular number here, well, then we multiply this number by this whole number up here. And what we do is we say 1 multiplied by 1 is 1, 1 multiplied by 1 is 1, 1 multiplied by 0 is 0, 1 multiplied by 1 is 1. Okay? So now that's this particular number done. So now we need to move into the next number, which is 0. But as we move in to the next number, well, we also indent and we move in down here, because the order and the position of the number indicates the order of that particular number. So we move into 0, we move in one, column here as well. Now we say 0 multiplied by, well, each digit, as we see up in the rules up here, wherever we have 0 multiplied by something, well, the answer is simply going to be 0. Okay, so we say 0 multiplied by 1 gives me a 0. 0 multiplied by 1 is a 0. 0 by 0 is a 0, and 0 by a 1 is a 0. Okay, so now that's the second digit done. The last digit is simply 1 again, but now we indent in a further step. And we say 1 multiplied by 1 is a 1, 1 multiplied by 1 is a 1, 1 multiplied by a 0 is a 0, and 1 multiplied by 1 is a 1. So now what we end up getting here is a simple addition now, and we follow the simple binary addition rules, right? And just to recap very briefly, so we say the addition rules. Well, we have 1 plus 0, this is going to be equal to 1. 0 plus 1 is equal to 1, and then 1 plus 1 is equal to a 0, but then we have to carry the 1. Okay, that's just our addition rules. And there's a short video to go through that if you want to take a look. Okay, so now we look here, so we say, well, 1, then we just get rid of these arrows here. And effectively what we have below these is, I'll draw these in black just so they stand out a little bit. We can write in a 0 here, and a 0 and a 0. Okay, so this is effectively what we're doing here. Okay, so we say 1 plus a 0 plus a 0. Well, this is going to give me a 1. 1 plus a 0 plus a 0 is a 1. 1 plus a 0 plus a 0 is a 1. 1 plus a 0 plus a 1 is a 0. Carry the 1. 1 plus a 0 plus a 0 is equal to a 1. And 1 plus a 0 is equal to a 1. So now what we're saying is that if we get the number 1011 multiplied by 101, well, this is equal to 110111 base 2. Okay, cool. So now we have our number, right? So we have our answer, and the proposed answer is 110111 base 2. So all we need to do now is to check this number. Okay, so let's take this number down here. Okay, and what we'll do is we just write this number out again. So we say it's a, oh sorry, a 1 1, oh, and we get sorry, black. They say 1 1 0 1 1 1 base 2. So now again, a simple conversion into a decimal is an expansion. So we identify the least significant digit, write a 0, and then count 1 2 3 4 5 from right to left. And now what we want to simply do is actually expand this out. So we're going to take the number, right, which is the 1 here. So we say 1 multiplied by the base of binary, which is 2 raised to the power of the index, which is 5, plus 1 multiplied by 2 to the 4, plus 0 multiplied by 2 to the 3, plus 1 multiplied by 2 to the 2, plus 1 multiplied by 2 to the 1, plus 1 multiplied by 2 to the 0. So now let's just go through and work these out, and then we'll add them all up. So we're aiming for 55, okay? So if we have 2 to the 5, so we go up in our powers, so we have well, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is going to be 32. So we say 32, which is 2 to the 5, multiplied by 1 gives me a 32. 2 to the 4 is 16, multiplied by 1 gives me a 16. 2 to the 3 is 8, multiplied by 0 is going to give me a 0. So 0 multiplied by anything is a 0. 2 to the 2 is a 4, multiplied by 1 gives me 4. 2 to the power of 1 is a 2, multiplied by 1 is 2. And then we have 2 to the 0. Well, anything raised to the power of 0 gives me a 1, multiplied by 1 is a 1. Now if we add all these together, well, we get, let's add the 16 plus the 4, which gives me a 20, plus the 32 gives me 52, 53, 54, 55. So, oh, that looks a bit like a dodgy 55. So we can see that actually what we ended up getting was 55. Okay, so let's just have a little recap here. Okay, so binary multiplication is, we can say, is quite simple. Right, we can say that there's very simple rules. So 1 multiplied by a 0 is 0, 0 multiplied by a 1 is going to be a 0, 1 multiplied by a 1 is equal to a 1. Okay, so we take those very simple principles, and now all we need to do is expand it out, be careful of the order of the number, and then it's simply back down to binary addition. Right, so once we multiply it out in this example here, we followed the binary addition rules, and we saw that we could multiply 1011 multiplied by 101. We get 110111 base 2. To then double check on this, well, all we wanted to do then was to expand this out in a position value number system, and then we end up getting the number 55. Okay, so this should hopefully make sense, and if it does, that's great. So all that's left to do is to draw our little happy face. Okay, thank you.